Hello and welcome to this KNX RF Energy Harvesting Webinar. My name is Christophe Partoens, the presenter of this webinar. First, an overview or the agenda. I will start with the overall picture, as I call it, the overall picture of KNX. I will then talk specifically and short about RF devices in general, then specifically the role of ETS5 in this context, and then I will address the topic, the actual topic that I have foreseen for today: energy harvesting. So semi-directional devices, configuration, battery, non-volatile memory, precompiled frames, limitations, timing aspects, and a development stack that is available on the market for energy harvesting products. Okay, so KNX, the overall picture. So here we see where it all started, so with KNX twisted pair. Then later on, KNX powerline has been added, and in order to combine KNX TP with powerline, a so-called media coupler was introduced. The same then happened for RF, so that is the, let's say, one of the latest developments in KNX, so the KNX RF communication medium. But also this can be combined with twisted pair and powerline, and also here a so-called media coupler can be used. Okay, and then there's also the possibility to extend such KNX installation or to link other KNX installations together, and this can be typically done with KNX IP. And all of that, so such an installation is entirely configured, or let's say the configuration details are actually stored in ETS, or better said, an ETS project. So every ETS project corresponds with a KNX installation, so to say. So that's the overall picture. RF devices then. So in general, RF devices have RF domains. And an RF domain is actually a collection of RF devices, or a subnetwork. And such a subnetwork has a theoretical maximum of 255 devices. However, reaching this maximum is not easy because it's an open medium. So there's some it is really vulnerable to interference. Therefore, retransmitters have been introduced. So in order to improve the communication between the devices of an RF domain, that means that some of the RF devices have a repeater function on board. So not all of them, but some of them. And for maximum 3 devices per RF domain, this repeater function can be activated, right? So in order to improve the communication. RF domains are as such identified by the RF domain address. The abbreviation for that is here on the slide, RF DOA, and is 6 octets long. So that means if we have a collection of RF devices that have the same domain address, well, then they belong to the same RF domain. As simple as that. For the runtime, it's important to understand that here in this context, extended group addresses are used. So in the, let's say, the regular group address, which is 2 octets long, they are used typically in twisted pair, but here we have an open medium, so we extend it with the 6 octets of the RF domain address, and this in order to distinguish indeed the my installation from my neighbor's installation. Otherwise there's interference. What we don't want, what we want to avoid, is that someone is controlling the light in my kitchen, or of course the light in my toilet. Right. Next, RF devices. So there are 2 types actually. So KNX RF ready devices, which have a single channel. That means there's one scan frequency, What this means that is, of course, that these devices are vulnerable to interference. So if exactly on the scan frequency there's some interference, then no communication is possible at that moment. Therefore, RF multi-devices have been introduced, multiple channel devices, so multi stands for multiple channel. They have, however, an RF ready mode feature on board, so they will be able, the RF multi-devices are able to recognize RF ready devices and will be able to communicate with them, so they are actually, so to say, compatible. RF multi-devices have 3 fast scan frequencies, of which one of the scan frequencies is the exact same as for RF ready. You see here F1, also here F1, same as for RF ready, and then there's F2 and F3, so other fast scan frequencies, in order to avoid problems because of interference, and also 2 slow scan frequencies. You might wonder why fast, why slow? Well, that depends on the role of the device, so to say, or on the application type. So typically, if the device should control is used for controlling a heating system, well, then it can be slow. If it's, however, if the device is used as a push button example given, then rather fast scan frequencies will be used, because then in that context we expect from the device fast reactions. Of course, slow and fast, the difference is, of course, the use of energy, the use of the battery, right? So that's an important aspect. The faster the scan frequency is, or in other words, no, what I mean actually, fast scan frequencies indeed consume more energy than slow scan frequencies. Could be an important aspect. Certainly, if we consider energy harvesting, of which what I will explain later on. There's also an aspect that is called RF frame duplication prevention. So that's also important in this context. You will understand later on why. So for now, I just want to explain to you what how RF frame duplication is prevented. Well, that is done via the transmitters, so via the devices that send information. So what they do is they insert a 3-bit LFN, so a data link layer frame number per RF frame that is sent. So in practice, it means when such a device sends a telegram, a first telegram, the counter will be set to 0, or the frame number will be set to 0. Next time it will be set to 1, 2, 3, 4 until 7, and then it will go, and then it will overlap to 0 again, just to just to prevent duplication. So if indeed a receiver then receives a 0, and next time again receives a 0, or it receives a 5 and next time again a 5, then it means that the second 5, so in this example, needs to be discarded. ETS5 and RF devices. Well, in most of the cases, RF devices will be used as an extension to a twisted pair installation, actually. Well, in that case, media couplers are used, and in that case, it means that this media coupler can also be used in order to have access for ETS to these devices via this media coupler. So the media coupler in this case serves 2 roles. So the media coupler as such, so for routing let's say messages or telegrams during or at runtime, but it can also be used for management. If, however, the RF installation is a native installation, a native RF installation, so only RF devices, well, obviously also then there are still you still need the possibility to have access for ETS to those devices. Well, in that case, you need to use the alternative, which is the which is an RF native USB interface. They are also offered by some of our KNX members. Okay, then the actual topic of energy harvesting. So energy harvesting is about self-sustaining KNX RF devices. That means they have no external energy source. These devices are at runtime unidirectional. That means they can only send information, so they cannot receive information. They cannot receive telegrams. That means that a battery is still required, and this specifically in the context of configuration. Because during configuration, such device needs to be bidirectional, otherwise it cannot be programmed. It cannot be configured. So what is the concept of an energy harvesting device? Well, that is to transform environmental energy into electrical energy. That can be done mechanically, because of the energy used by the user that manipulates rockers of a push button. So because of pushing and releasing rockers, some mechanical energy is then indeed transformed into electrical energy. Light radiation could also be an option. The energy could be transformed in because of the thermal it's called, because of heat actually. Heat that is then transformed into electrical energy, and in the future also such energy could be transformed via RF. All these devices are ETS compatible, and what I also can say is that there is at this very moment a stack available from at least one member company, and that's member company TAPCO Technologies in this case. Others might follow in the future. Semi-directional. What does it mean? So as I said, at runtime, the energy needs to come from the environment. Unidirectional means it's the default mode, and this in order to save energy. So indeed, by default, all these devices are unidirectional, purely because of the sake of saving saving energy. Because especially here in this case, there is not even a battery. So at configuration time, a battery is required, which is also called a programming adapter, by the way. So this battery is there in order to make the device bidirectional, so that it can also receive telegrams. There's also one extra aspect that comes to this, that is that programming as such, so the following or performing or using a load procedure implies resetting. So because of the battery, the device knows that such a reset during this load procedure is not a regular reset, because a regular reset will put the device always back into the default mode, which is unidirectional. Here, in this case, because of the battery, the device knows, okay, reset means in this case, don't come back to the default mode, but come to the programming mode if you want. That means the device will, after the reset, remain in bidirectional mode. So that is also a reason why a programming adapter is used. So in order to make sure that the load procedure can be carried out properly or successfully. So here we see the configuration battery. So here we see one example. So it could look like this. So the programming adapter will be inserted. When it will be inserted to the device, it will reset the device. The device will then, after this reset, run a low power application. That means low power application means there will be no button interfacing. This will go on for 2 seconds, and then the device indeed knows, okay, it seems that there is a battery present here. That means I have to put myself in full bidirectional mode. At the same time, also the device will switch the programming LED on, so that indeed for the user it's clear, yes, the device is in programming mode. This also as such means that by just putting the programming adapter, that no programming button is required here in this for this type of devices. Sorry. Okay, then after programming the device, or better said, the adapter will be removed again. That means that the device will be switched back to into the default mode, which is the unidirectional mode. Non-volatile memory. So there's also a very specific. This is also a very specific aspect to these devices here. That is that because of the fact that devices switch off, so go into sleep mode between user manipulations, because of no battery, no energy source, external energy source at least. That means that for group object values, they always need to be reloaded before each user manipulation, so in order to have the latest value. Also, it means that the group object values need to be stored after each user manipulation in order to update the value. Also, the type of rocker manipulation needs to be remembered. Was the last time that the rocker was used, was it used with a short action, so just a click, or was it a long action, so a push? Or was it releasing the button? That could also be a type of manipulation. So we have to distinguish 3 types of rocker manipulation here. Also, the LFN, so the data link layer frame number, so the frame number needs to be remembered. Also, that needs to be stored in the non-volatile memory. And because of all that, well, we can say that memory access time is really critical. It needs to be very fast. So because of the simple fact that by the time the device goes back into sleep mode, all this information needs to be stored, right? So therefore, memory access is indeed time critical. Also, in order to save energy, the so-called precompiles RF frames will be used. So frames, telegrams actually, are precompiled and stored into memory. These precompiled frames are divided over 2 data string blocks. The first block contains a data string per supported data point type size. The second block then contains information which is based on the onboard number of rockers. Now, just to explain this to you with an example, let's take the example of a 4-fold push button, where each push button or each rocker could be configured as an on-off function, as a dimming function, or a blinds function. Now, in order to know how much strings that we need in the first block, let's have a look at the group objects. So, in total, there are 5 group objects. There's 1 bit for on-off, 1 bit for dimming, and 1 4-bit for dimming, and blinds have 2 times 1 bit. So that means in total we have 2 types. We have 1 time 1 bit, 1 time 1 bit, and 2 times 1 bit. So we have 4 times 1 bit indeed in total. So that would be the first frame in the first block. And then there's also a 1 time a 4-bit. So we have 1 4-bit. So that means that's the second frame that we will need in the first block. The second block then? Well, because of the fact that we have 4 push buttons, because of the fact that we need to remember the action type, so this number needs to be multiplied by 3. So 4 because of the 4 rockers, 3 because of the action type, so push, long push, or release. So multiplied by 3. And then of course LFN, the data link layer frame number, which is 8 in total, so from 0 to 7. That means in a total we will need in the second block 96 precompiled frames for this device, for this 4-fold push button. Why do we need these strings in a precompiled way? Well, as I said right from the start, that is in order to save time, because everything needs to be done quickly. So the frame that needs to be sent out needs to be precompiled so that the device can retrieve it immediately or nearly immediately and send it out also as quick as possible. All this in order to save energy. Energy harvesting devices have some limitations, like the long push is limited in time, and this especially is the case when the release action indeed doesn't generate energy. So especially then long push is limited in time. The release action is not available for all types of energy converters, so there's also something to be taken into account. The listen before time is limited. If the medium is really busy, frames can be lost. Also could be critical. Some hardware requirements like the wake-up time, the clock synchronization, really limit the selection of microcontroller units and or RF chipsets that can be used. So you need to be careful in your selection there because of timing aspects. I have explained to you about RF multi, but of course RF multi devices consume more energy than RF ready because they have the possibility to change the scan frequency. Changing scan frequency takes, however, energy. So therefore, the reason it might be that combining RF multi with energy harvesting might simply not be possible because of the lack of energy. KNX Secure, so with a lot of, let's say, encryption. Encryption also takes time. Encryption means calculation. Calculation means consumption of energy. So also here, as such, it is not. It is allowed to combine KNX Secure with energy harvesting devices. Of course, no problem. But it might simply not be possible because of lack of energy. So that is actually some of the limitations, some of the constraints that we wanted to point out here. Okay, then some time frame and frame timing aspects that I want to illustrate to you here. So here we see a monitor where several signals are recorded or displayed. Well, here this is the moment where the user has been manipulating where the manipulation of the rocker actually started. So the push is here, takes place here, starts right from there. Then there will be right after some listen before talk time that will take place. So there will be some time. A little bit of time that the device will wait before reacting to this push button or to this rocker manipulation. So here the rocker manipulation started right after or nearly right after the listen before talk starts. Listen before talk stops here, and then the device will react. Will start with the reaction. So it will retrieve a precompiled frame from the memory. And eventually it will then indeed, so this will take a little bit of time as well in order to retrieve it, in order to make it ready for sending. The sending will then take place here, so it will then transmit indeed the precompiled frame that has been retrieved, that has been set up. And the actual sending, of course, means that more energy will be consumed. That is what we see here in the purple curve here. So here the energy consumption is moderate. So that's so that's the RX part. So the receiving part, so to say. So not much energy is consumed here. The let's say the preparation of the frame to be sent also takes a little bit of time. Takes a little bit of energy, but not so much, right? So again, here is where it starts. So this is just listening, so that doesn't take energy. Here, this is calculation of the preparation of the frame to be sent. Takes a bit more energy. But it's actually when the telegram will be sent out that really there will be an increase of energy consumption. And this is the yellow. Well, yellow is the total energy that is available because of the push of pushing the push button. Okay, then my last slide actually already for this topic for today is about development. So the certified stack that is available. As I said, there's a stack indeed available for KNX Harvesting Devices from member company TAPCO Technologies available. It's actually based on a product that that already exists in another for other medium. There's a twisted pair version, etc. So the product is called a KAI stack, and which is now also available for these self-sustaining KNX RF devices. And the stack is ETS compatible. So if you would base a product, a KNX product, on this certified stack, then this product will be ETS compatible. Well, and then for now, I have presented everything that I wanted to present to you. So I will now just end the webinars by showing you still a few extra slides with some extra information. And while doing that, or before doing that, I want to thank you for your presence here. I want to thank you for your attention. And maybe we see one another in one of my future webinars. So for now, thanks again, goodbye, and have a nice day.